let's go through LeetCode 489, robot room cleaner. So this question, let's design a robot that is going to clean a room. The robot give us the method move, turn left, turn right, and clean. So let's implement those kind of clean algorithm to clean the room. Here, the robot give us, let's look at the interface. The move is that it says that if the next cell, you are able to move, then it will stay to the next cell and return true. And if it is next cell is a wall, then all obstacle, right? Then I cannot move to the next cell. Because there is no grid here, right? So the thing is that we can only use a move to tell whether the robot can move to the next position. So the thing is that if this move return true, that is this is our current position. And if, for example, we are moving on the right direction, if this is return true, the next position will be here, right? From here to here. If this is return false, that means I can only stay here. So let's design an algorithm to let the robot to clean the room. The thing is that because the room is we don't know what's the boundary. There is no boundary actually, right? So the robot is initially state at row 0, column 0. So what we think about is that how can we design this kind of algorithm, right? So assume the robot is at a row R and a column W, right? So we design an algorithm that it can try the 4 directions. For example, let's say right, down, left, up, right? So initially we don't know what's its position at rows, this row and column, right? So what we're thinking about is that maybe we need to have a direction as a third element in our array, right? But the thing is that we're thinking about it carefully that actually this direction is, we don't care about it because we tried the 4 directions. For every cell, we try the 4 directions, right? And we know cell it has a row, column, and direction as a state. But the thing is that for this one, for every cell actually we are trying to try 4 directions. So that the thing is that we can ignore the direction dimension, right? Just use a row column to represent whether we has cleaned this cell or not. Initially, this robot is moving in that direction to go up, right? So when we have a direction array, let's say the index 0 will be go up, and then turn right, turn down, and then turn left, right? So doing a clockwise change. So the thing is that we need to say that when this robot so the thing that we design the algorithm that is if the cell has already been weighted, then our robot we don't need to visit it again, right? Otherwise, it will be do some kind of redundant work. So if it is weighted, we consider this as wall or obstacle, right? That is the same as move equals force, right? Then, if we in this kind of scenario, if we turn directions, and we just try 4 directions, right? So if we already tried 4 directions, and and we try then we tried the for this kind of steel, right? We don't need to. That means we finish the operations of this steel. We don't need to do this again. So the thing is that if we are able to move to the next step, right? So we can DFS using from the new position. And after DFS to the new position, what we need to do is that we need to backtrack, right? So backtrack is because the original position is, for example, we are going to this kind of direction. What we need is that we go to we are already on the position of the next cell, right? So in this kind of direction, what we need to do is that we turn right again. That means we move direction, change it to up reverse. Then we call move, right? And then go back to the original position. That is the backtrack process. Um, so so this will be the whole process of how we design this kind of robot. Then let's write code for this. We know this kind of robot initially it is moving up, right? The direction is going up. So let's just have direction array d row equals. So go up we'll see the row is going to decrease 1, right? And then we move if we are doing the moving clockwise. So the next direction will go right. So it will be 0, right? And let's say decolon as well. So this is going up. Then go right, we have column increase by 1. Then go down, right? The row will increase by 1. And this go down and go left, right? That will be the column will decrease by 1. So this will be our direction array. And the things that if this kind of position has already been weighted, we're not going to weight again, right? We can use a string to represent which row, which column it is, right? So we'll say weighted equals new hash fact. So we'll say, let's say DFS robot and weighted. Initially, we are at position row 0, column 0, and our direction is going up, right? So we're going to have private void DFS. We need to have this robot and set activity. And we have a row and have column and have direction. So we're going to have a string position, right? Because row plus this one plus column and um, that have related at this position. And if we are able to stay at this position, we just have robot clean, right? And then we try the four directions. So when we enter this kind of direction, we don't know what this DRR is, right? It is maybe 0, maybe 1, but we can try the four directions. So what we do is for into k equals 0, k smaller than 4, k plus plus. So we'll say int new row equals row plus d row k, and int new column equals column plus d column k, right? So we'll have a string new position, okay, equals new row plus new column, right? So we'll say if the new position is not visited, and we are going to move, right? So let's say robot move. This move do two things. One is that it will try to judge whether the new row, new column is able to we are going is we, the robot is going to able to move to that position, and also it moved. So if we call this move, we change to the new position, right? So we do DFS, right? Do DFS something, and because we moved, so we need to do the backtrack for this move, right? So this move is not only return true or false. If it is true, it also moved. So backtrack is that we need to return to this or to this original position, right? So what do? We can right, turn right, and move call again, right? So that's a DFS robot related new row, new column, dir, and let's write a backtrack robot. So what is backtrack? Um, so backtrack, we'll say in order to return to the previous position, right? What we need is we need to have a robot turn right, right, turn right, turn right. We can also turn left, right, turn right. Have a robot turn right again, right? and then have robot move. So the things that we know for a robot, it has three states: row, column, dir. Let's say originally, for example, if we go to this direction, right, and when we backtrack, let's say it turn right and turn right, and when we return to this kind of original position, let's say that the direction is going reversed, right? So let's say it's not the previous state. So the backtrack, after we move, we should still turn right, or we can right, turn left, whatever, right? So we still need these two lines to make sure its direction is also original, right? So for this four direction, right, we need to keep in turn right. So robot turn right. For every direction, we need to try turn right, turn right to try the four directions. And when we turn right, we'll see that DRR to also change, right? So DRR equals DRR plus one mod four, right? So this will be our code. So it looks like some lines has been recursively called. Um, Related at this position. 35. So looks like a new position. We we the things that this one should not be K, right? Should be DIR, right? This one be DIR because initially we don't know because when we enter new cell, it is um in the direction of DR, not in the direction zero. Um, so this will be the code. And let's also write a Python code for this. And let's have d row equals. So we say initially it is going up equals zero, right? So then if we do clockwise, then we are going to going right? So it will be zero. Our column will increase by one. Then we go down, right? Go down, our row will be zero. Our column will be zero, right? And then go left, our column will be decreased by one. So our main function is that we need mm, we can have visited equals set, right? And in Python, we can use tuple, right? Instead of compose this as string, and put the tuple into the set. And we'll say DFS. We already have robot related 0, 0, 0, right? So let's write the font if DFS and visited. So the visited will be uh, visited, right? And the row column 加2, right? So visited, we are going to add tuple row column. And also we'll have robot clean, right? Then we try 4 directions for k in range 4, right? Then we'll have a new row equals row plus self dot d row, okay, d row dir instead k, right? And new column equals column plus self but the column, yeah. So let's say if this tuple new row new column not inverted and robot move, right? Just move. Then we're going to DFS weighted new row, new column, DR, and we should have back check robot. Back check just this, right? Because robot is in the main, we don't need to. Then for these 4 directions, what we do is that we need to have a robot turn right, and also we'll have dir equals dir plus 1 mod 4, right? So let's write the function of backtrack. So the backtrack is our robot should turn right. And the robot got to move, right? So we'll say doing like this, the direction is reversed. So we'll turn right and turn right, turn right again. Let's call it the direct, so that it's a direction, right? So that it is not special keywords. DFS related invariant syntax, new row, new column, direct. It is, this is Python, right? So we should not have this. Okay.